What's that? Does it say?
This is saying I'm muting my microphone.
The people one on the left. What is that? No, right where.
Now I can. Wow, sharing the link.
There you go.
Sorry. It's saying 0 watcher so far. Okay, let's see what this is saying. Chat. My first stream ever. Okay, somebody just connected. Hi.
Hi, can you hear me okay?
I can hear you. Can you hear us?
I can hear you, yes.
Okay.
Okay.
Cool.
Okay.
This is sort of question. Can you hear me?
Well, not necessarily.
I'm just.
It's like a knack. Act.
Okay. Yeah, this is not the. Sorry, I just. No, it's. I'm just thinking, how can I? There's an external digital web camera, and right now the Hangouts using my laptop built-in digital web camera. Ooh, cool. Can I?
What's that? Someday we're going to learn how to use this.
Yes. Sorry everybody for the technical difficulties, but this is our first ever. This is my first ever Hangouts, and I'm still trying to configure the settings. So please bear with me. Okay. Okay. I will try to mute everybody's microphone. Please, can everybody hear us on the Google Hangout?
I can.
Okay. This is it's funny because I try to mute everybody microphone, and according this the microphone is on, is still working. So who will be the presenter?
I guess. So does that mean I have to wear the headset? I guess that means I have to wear the headset. Okay, just point the laptop at me.
Okay.
Hello, everybody. My name's Rick. Oh, this is weird because I'm talking to people in the room with the headset on, and that just seems wrong. Okay, let's see. How's this? There. Now I have one ear free. So our normal host and leader, Sean Roberts, could not be here today. I guess I'm the vice host, or the default host. I work here at HP. Lisa Roberts, who's also one of our co-hosts, she too could not be here today. So this is my first solo, but I do have Alina. Is she here? Alina's your hostess, and she's the one basically making sure all this happens as far as logistics go, and I deeply appreciate her help. How many of you have not been to one of these meetings before? Okay, so let me explain a little bit about our OpenStack meetup. Sean Roberts used to work at Yahoo until about a month ago, or month and a half ago. And for the last year and a half, he's been hosting these OpenStack meetups at Yahoo. He was a director at Yahoo, and his story was he's also on the board, or he was, as the Yahoo representative, on the board of the OpenStack Foundation. So he's quite an important person. As a director at Yahoo IT, Yahoo was shifting their entire infrastructure over to OpenStack. And as one of the directors of IT, his job was to hire OpenStack engineers, and he found out that that was rather hard. So he started this meetup, originally I think just more as a hackathon, but then he realized what he really needed in his professional life was more OpenStack savvy engineers. So he started a training, or moved this meetup to a training flavor. I've worked at HP for 7 years as a training developer. As of a month ago, I switched to being what's known as an evangelist, which is basically a fancy word for a trainer who travels a lot. Sean left Yahoo and therefore could no longer host these meetings at Yahoo, which obviously requires badge access and guards information stuff. Our other co-host, Lisa, arranged with Sean to have it moved to our facilities because we have badge access and guards and the whole bit. Sean now works at VMware, just for the information. One of the nice things about moving it here is it's not far from Yahoo headquarters, so the regulars who come to our meetings didn't have far to travel. We're also very blessed for this meetup, for the hackathon meetup, to have this room. This is what we call a customer briefing center. Normally, I don't get to come in here unless we have customers. Lisa and I convinced the owners of this room that you all are customers, and so they're allowing us to, every 2 weeks, we hold the hackathon meeting in this room. Now, that said, the other thing Sean did, which I think is very confusing, is he has a once-a-month beginner meetup. So the first Thursday of every month, there's a beginner meetup and this hackathon meetup. When we hold it here, the beginner meetup is down the hall in our cafeteria, and this hackathon meetup is still here. You can kind of think of the hackathon as being an advanced meetup. So we consider it for people who already don't need the beginning material. That said, we are mostly focused on training for now, so we will be going over some basics. And one of the things we've done through Sean's guidance is we've put up a training manual. Ooh, not this page. The training manual here, which is docs.openstack.org/training guides. You'll notice it says docs.openstack.org. So we are technically part of the Foundation's documentation division. The documentation division, besides putting out or maintaining the manuals, also publishes books. There's a very good book called The Operations Guide. And there's another one called, I think it's called The Security Guide. And there might be a third one that's, the name is escaping me. Maybe it's the Network Guide. Architecture Guide. I'm sorry, the Architecture Guide. Those books are real interesting in that the leader of the Foundation's documentation division brings together experts into a meeting, not unlike this, and they will do what's called a doc sprint, a documentation sprint, and in a week they will pull together a book. The other interesting aspect about the documentation sprints, for the most part, O'Reilly has donated their time to take the XML doc book that's produced by the sprint and then convert it into the major ebook formats, and they will publish the book on paper. And you can buy any of those for around $30. Or you can go to docs.openstack.com and download them for free. I don't quite understand that business model, but bless their hearts. O'Reilly's a huge supporter of open source and restriction-free publications. So let's see, does that cover everything I want to talk about? Oh yeah. So one other thing is, now that we're hosting this meetup here, I'm starting to feel like these two meetups that overlap once a month but don't overlap once a month, I'm beginning to feel that that's a little complicated. And because every time I start one of these meetings, I have to explain what I just explained. One plan that I've suggested to Sean, and he seems open to, is that maybe what we'll do is we'll hold the beginners meetup at the first Thursday of every month, and then the second Thursday of every month we'll hold this meeting. And more in the up till now, the hackathon has really been more like an unconference where we just basically talk about whatever. But I want to move it more towards the spirit of a hackathon or maybe an install fest where we take the topic that was discussed in the beginners meeting and maybe bring our laptops here and then try to implement it, what we learned the previous week. And then we can also hold advanced sessions in our little lounge here. So if we do have advanced players who want to discuss deep topics like configuring a cinder blocks or who had networking issues? Bill. Bill, you're here today. Bill was having networking issues that we could not solve, but that sort of thing. We could hold an advanced discussions in the next room while we try the install fest sort of thing here. I'm thinking we'll start that the beginning of 2015. And unless you guys have better ideas, this is somewhat of a democracy, so again, you can either speak up now or chat in the chat room, in the chat area for the meetup. And again, if you have other ideas, we're really open to other ideas. The main thrust of the meetups in general, all meetups really are for distributing technical skills and technical knowledge. And one reason I became an evangelist as opposed to my training job was I get to host more meetups and events like this. So I'm actually very happy with that. My idea of a good time is not necessarily to go to a sporting event or long walks on the beach. My idea of a good time is to go to meetups and hackathons. So where were we? Any questions on the video hangout? Nope. Okay. Seems like there's something else I need to talk about. But that said, for those of you online, if you can go to docs.openstack.org training guide, we're just basically going to walk through the training guide and explain how it's structured. I was kind of hoping to start at the third chapter because that's, to me, the best written chapter in the whole set. That's what I wanted to talk about, installation. So part of the reason why we're bifurcated here with the hangouts and the display and all that stuff is because this sad laptop is dying. And I am going to put it in its grave as soon as I can. I have a new laptop on order, and hopefully next time I'll be able to do more stuff, including demonstrations. I kind of thought I would have that laptop by now and be able to show you some demonstrations, but bureaucracy at HP the way it is, the order's been delayed indefinitely. I don't know when I'll be getting that. So again, I apologize for not having a really slick demo today. We're just basically going to walk through a website and look at the pictures there. How many of you have experience with OpenStack? Okay, good. How many of you have jobs dealing with OpenStack every day? Oh, same peoples. Okay, good. So again, part of the issue with the training is we kind of, I'm a strong believer that training does not exist until you do hands-on, until you actually do the experience. And one of the conundrums of training, especially in enterprise software or large software, is the installation of that software usually is an advanced topic. It's not a beginner's topic. So we have this chicken and the egg problem. Part of the way we have to help the beginners get hands-on training, but they can't get hands-on training until they've installed the system, or at least have somebody install the system for them. And if installing the system is an advanced topic, then we just have a lot of problems. There are solutions around this. None of them have proven terribly viable yet. One of them is to use a thing called DevStack. That's actually the second one I was going to use. So let's go to DevStack. DevStack is basically a bunch of scripts that will install a minimal version of OpenStack on a laptop. You either need a Linux laptop or you need a laptop with Linux virtual machines. It's well documented. It's not that hard a process if you're used to command line. If you're a sysadmin, it's really not that hard at all. It does require, I think you need 16 gigabytes of hard RAM in your machine. You really need to bring up at least two 8 gigabyte virtual machines. And that should be sufficient to run a baby version of OpenStack. It's called DevStack because it's for developers. It's for people who are coding against OpenStack. And our good friend Mike Perez, who did not make it today, has the greatest t-shirt that he invented 2 summits ago. It says, hey, it worked in DevStack. But the idea is you get your code working on DevStack. Then, sorry, we're having feedback issues. Then, okay, they're gone. I don't know what happened. Okay. Then you check it into this large continuous integration system, which we covered last session. You check your code in. First of all, you test your code using the test harness that you can download on your machine. You can actually run that in DevStack. Then you can upload it, and it goes through the test harness again. And then it goes into a queue where there are reviewers. Any of you can volunteer to be a reviewer. Some reviewers have more power than others. As a neophyte reviewer, I forget the exact waiting period, but I think you have to wait a while before you get 1 vote. And if you're an expert commiter, you get 2 votes. And basically, for anything to be rolled into the branch, to the main trunk, you have to have +2 votes. And of course, it could get -2 or -1, in which case you get irritated and fix your spelling or whatever, and then resubmit. 2 sessions ago, Mike Perez actually did a live review for us, and it was very cool. He just picked something, and I was flabbergasted. He just said, well, looks like it works. Pressed the button and gave it his vote. So the last 2 meetings we did cover the continuous integration stack. I find that continuous integration stack actually a lot harder to get up and running than I found DevStack to get up and running. There's something called tristack.org. And I had it working just fine, and that's a hosted version of OpenStack. I recently found out it's hosted in Asia, which I thought was real interesting because it was working for me fine until I tried to demonstrate it here 2 sessions ago, and it wouldn't respond at all. And the theory is that basically Asia woke up and started using it, and that's why it didn't work in the evening. So that is a really good option. There are other hosted versions of OpenStack. We happen to we're actually right in the building where HP Cloud is, most of the people for HP Cloud work. So HP has its own public OpenStack deployment. Rackspace has their deployment. I think Red Hat has one. Does Red Hat have a? They do have one, yeah. And IBM, of course, they all have. Now, in general, I don't know what the financial arrangements are. I know HP gives away a free account with some limits, usually a time limit. I mean, even Amazon Web Services gives away free accounts for developers for time limits and whatnot. I'm pretty sure Amazon Web Services is absolutely not OpenStack. That's a good question, actually. So Amazon Web Services is the granddaddy of public clouds. They are the big gorilla in the room, or the big elephant in the room. They got basically a 5-year head start on anybody, and Jeff Bezos funded that. It's not even clear they're making money because it's very private. All their APIs and everything are private implementations. They are slowly opening some of the API. Those APIs are open. You can program to their APIs, and some of their implementations are being opened up as well. Interesting you should mention that, because there's another company called Eucalyptus. How many know what I'm going to talk about Eucalyptus? Somebody just bought Eucalyptus. Oh wait, we bought Eucalyptus. Go figure. Eucalyptus is a real interesting company. It's actually older than OpenStack. They started before the OpenStack Foundation started. And they basically took the public APIs of AWS and re-implemented them from scratch. So they had their own implementation. It's purely open source. They hired the CEO who used to run MySQL, which was one of the larger open source projects, which got sold to Sun, which then got sold to Oracle. So Martin Mikos has made an arrangement with HP to bring Eucalyptus into HP, and currently the deal has not gone through. He's very clear on this. I just happened to see him talk two days ago. The deal has not gone through, but chances are in a month he'll be my boss. Well, way above my pay scale. He'll be several levels above my pay scale. He will be the vice president in charge of these two buildings and all the rest of HP's cloud. Well, it's a total lie. Let's just say HP Cloud, and I'll drop it there. There's more machinations than you care to hear about how HP is structured. So the question then, the other interesting part about that is Eucalyptus has never been terribly friendly to OpenStack, and Martin Mikos has really not been. He's been a big critic of OpenStack, actually, until about 2 months ago. Go figure. And a month ago, he wrote this great blog about how OpenStack and Eucalyptus really are buddies, and we get together, and everything's fine. And then 2 weeks after that, it turns out HP's buying Eucalyptus. In the short term, that really makes my job harder because now I have to explain AWS versus OpenStack, and we are very firm in our statements that we are going to support OpenStack going forward. This buying Eucalyptus does not mean we are abandoning OpenStack in any sense. We are one of the top 3 contributors to OpenStack financially and by people and by commits and by any measurement. Chances are you'll find it certainly in the top 10 in any particular project, and the top 3 if you measure overall. Red Hat, IBM, Rackspace, so maybe 4. Us. Anybody else is the big? Those are the 4 biggies. Cisco wants to be big. VMware, go figure, is very much a supporter of OpenStack now. Oracle is coming. EMC, all the storage companies and all the network companies are going to support OpenStack because they're plugins to OpenStack. It would make no sense for them not to support it. But again, they plug in as providers of their various product services. Excellent question. So there is Google and let's call it Microsoft. Apple iCloud is not really a player in this space. They provide services for like storage and some online other tools and mail, but they don't really play in this enterprise space. But Google and Microsoft absolutely do, but they tend to be in what's known as the PaaS space, that is the platform as a service space. Now, that said, they will also provide you infrastructure, and usually what we mean by infrastructure is a computer with an operating system, networking services, and storage, and support services at that level. Amazon AWS is the granddaddy of that model. Netflix has based a large part of their business on that model. Zynga has a great model where they come up with their game. You know, they make games, and basically they will, when they start a new project, it's completely on AWS. And then they have some sort of economic model where if it becomes popular, they switch it over to their private cloud. And I don't know how that works, but I thought it was a fascinating. It's an article I read over a year ago. I thought it was really fascinating. I also like to point out AWS stands for Amazon Web Services. They are so old that they started their business before cloud became a real popular buzzword. Because if they'd started it 2 years later, it would have been called Amazon Cloud Services. Back in the day when I used to work on J2E, we all talked about web services. Anyway, where was I going with this? Any more questions? Good question. So a little history. Actually, should I do the you guys, so the problem is I've done this speech so many times and I don't want to offend the regulars, but I could pull out my bulletin board and I could do my little chalk talk on that for the newbies. But again, I don't want to. What do you've been here? What do you?
This is the first time.
Your first time here. Okay.
Third or fourth time,
Yeah.
so, but it's always interesting.
It's always interesting. Al, you don't want to hear it again, do you?
No.
Yeah. Okay. I don't want to offend Al. Tell you what, I'll do it at the end. That way, we'll let Al go get some beer and he can sit in the other room and chat.
Sounds like a good idea.
You like that idea? I care about you, man.
I have another question.
Yeah.
I mean, in terms of production side OpenStack, what's your recommendation for? There are so many, quite a few, at least half dozen mainstream OpenStack commercial distributors.
Yes.
They also offer sort of like just like HP community edition.
Yeah.
So I would like to get an answer from which community edition is totally for free, but is suitable.
They're all for free to some extent or another. Okay, so there's the notion of church and state. The OpenStack Foundation versus HP and IBM and Red Hat and all the other commercial entities that support OpenStack. This is a foundation meeting. This is church. We won't go in. We tend to avoid the competition question here. I obviously have reason to suggest a certain brand, one of those, right? And you are more than free to talk to me once this session ends, understanding that I've now put on my HP hat. But we will make sure that that is very clear. This right now is a foundation meeting. So I'm not going to answer that question. That said, but DevStack is a foundation platform, and the instructions we provide here are foundation, are open source. DevStack is absolutely not for production; it's for development.
Are there any sort of community edition, free edition that is capable for a serious production deployment? I doubt.
So every distribution is technically, well, just about everyone is really. It comes down to what installer you're using and what reference architecture that installer is installing.
So it's just like Linux, where you have the community.
Exactly.
Enterprise.
Pretty much all distributions are grabbing the same bits from us.
If there was okay.
They're doing
Cloud
some
box.
packaging and packing.
Yeah, but I'm very much it's similar to how Linux is constructed, where you have the community, which is really have an enterprise that it will branch out and build to satisfy different markets.
Right. There's a very good article I'll refer you to. I believe the title is OpenStack is not a cloud. It's something along those lines. If you Google OpenStack is not a cloud, the fundamental bottom line of that article is that OpenStack has a good core center of the pieces you need to get a cloud running, and you certainly can get the cloud running. But when you get it running in a production unit, it's probably about a third of all the software you need. There's a lot of management software that needs to be installed and other things, and you can get some of that open source, but Certainly at HP, we certainly will gladly sell you the software. Well, we have our commercial edition of OpenStack as well, just as Red Hat has their commercial edition of Linux. And Linux, again, is just a kernel, right? And it's a kernel that has been blessed by a benevolent dictator. This was actually a topic at the OpenStack meeting at the Computer History Museum 2 days ago, where HP Vice President Martin Fink, who is our our open source vice president, he talked about open source software a lot. He pointed, in fact, when I said that we can get together in the foundation and everybody, and this is actually why I love OpenStack meetings, is you can really just talk about the technology and everybody's all gung-ho regardless. There's a saying we have in OpenStack, leave your badge at the door. But Martin Fink says that really has nothing to do with when we go to a customer, we will compete for your business against IBM and Red Hat and all the rest. And that's perfectly well understood, but we do keep church separate from state, so to speak.
So I had a more technical question.
Yes.
Something you mentioned earlier. You said that stack you need 2 VMs.
So yeah, that's a good question. It can be done in one, but they usually recommend it in two. And basically the idea is you put the hypervisor and part of the controller in one, but most of the other controllers will go in the first one. Right. Neutron and yeah, all the others. And that again, you can use one. All right. So yeah. If it's my personal belief that this time next year we'll be running all those controllers in containers, and then it really won't matter where they run, except that I'll have to run on a Linux box of some sort. But other than that, they'll just be deployed in containers.
What's the reason for the size? I don't see why you need, let's say, 8 gigabytes.
So each one of the controllers is a web service unto itself. Each controller has its own database. It has its own instance of Python code, its own library of Python code, and they run in separate processes.
But you should be able to do that with 500 megabytes.
Not 500 megabytes. That.
You used to run with 300 megabytes MySQL database, web server, all kind of stuff. I think if we just install Ubuntu 14.8, 500 cost more than 100. Well, you're going to install everything. I mean, they just load it with stuff like Windows people.
Okay.
That's why I need to go to.
Yeah, I don't know the answer to your question. Go. You've tried it with 4 gig? It was terrible. But it's actually, that's the minimum recommendation, but 8 gig is the practical recommendation. I don't honestly know. I understand what you're saying, but I don't know the answer.
My question, in addition to that, is it is possible to get it in one VM. In other words, all functionality of OpenStack can be put in one VM.
Or on one Linux box. You don't need virtual machine if you're running Linux. If you're running a supported Linux box, you don't need virtualization at all. You just run it. And
So I can just use it in my native.
I tell a lie, because when you deploy the target VMs, you're going to have a virtual. You're going to have a hypervisor of some sort. Bare metal, yeah. So actually, and this is actually a project I'm curious if you guys would like to run with. I think it's a really cool project. How many of you are familiar with the Raspberry Pi supercomputer? Why can't we take that and basically use it as target machines, right? And put a little light bulb on each one and basically have OpenStack on your laptop or something, right? And then say, deploy me a Linux machine, and it turns on the light bulb and says, that one is allocated. And they say, deploy me another one. Now that one is allocated, and then it rolls down all 12 or whatever, however many we have on the table. They all get allocated and say, deploy me another one, and it says, sorry, cannot deploy one. Then we free one up and we deploy the next. You know, I think it is a fun, cool little project, completely impractical except from a training perspective.
There is a project similar to that, but more expensive. I think it's Orange Box from Ubuntu.
Oh yeah?
Yeah, a little bit more
And
expensive.
it's about, I
Oh yeah. Orange box from Ubuntu. Yeah.
And I think it's OpenStack.
Yeah, but it is more expensive. And again, for $35 per, and with a case now, they come with a case for $35. That's really cool. We could just lay them on the table and get a router or a little tiny hub and. Oh no, it wouldn't be practical. The target machines would. I mean, you actually can do quite a lot with a Raspberry Pi, but I don't actually know what we would do with these Raspberry Pis except turn a light bulb on and off, which I think would be sufficient from a training perspective. Also, the interesting part of this project will be writing either the Nova plugin or the Ironic plugin. I'm not exactly sure which one you would do. I think you just do it. I think you just do it as a straight Nova plugin. In fact, I think there already is a Raspberry Pi interface in Nova, but it would just be a fun project. And again, it's maybe something we want to think about. So most of those articles I've seen have all been about running the controllers on the Raspberry Pi, since it's just a Python process. So you need, what, 7 controllers? So you get 7 Raspberry Pis, and you can put 1 controller on each. But yeah, well, 1 set of controllers. Right, you need your Nova. Theoretically, the only controller you really need is Swift. If you're just going to do storage, if you're just going to allocate storage. If you're going to deploy Nova, you could use old school Nova and do pretty much everything just in old school Nova. I'm not certain you can do that in the latest version, though. I don't know how Icehouse has broken that out. But canonically, you want to have Nova, Cinder, you need Keystone, obviously. You need Horizon. I'm missing. What am I missing? Did I say Cinder? I said Cinder. Neutron's the one. I never can think of all of them all at once. But we could do something like that. It might be fun.
I think it would be more practical to use mini IPX boards because you can plug in much more memory.
Yeah, it's practical. I wasn't thinking practical in this project.
And financially wise, if I compare to what I paid for 386 motherboard,
well, yeah.
So it was $2,000 maybe.
But that's Moore's law, right? Or we could wait 10 years and have it on a.
That much money would buy me quite a number of mini IPXs with maybe 2-core CPUs or something like that.
Right. So I guess this is your homework. Is I want you all to think about fun projects that we might want to do next year. That would be good training vehicles. Something that would help to train people and practical. Because one thing that this document does not do, this document really is more of just. It's really more of a manual. It's more of an operations guide than it is what I consider training. Again, for training, you need to have hands-on experience, and you can go through the hands-on experience, but it's done to do the task, not to do something interesting with OpenStack. All right.
Yeah, that's exactly my question.
Do we have commercial training? HP has 5 groups doing commercial training on OpenStack. We're not the only ones that provide. There's a page. I don't know where the page is, but on OpenStack.org, www.openstack.org, there is a training page that lists all the companies doing training. Our good friends across the freeway here, Morantis, they usually are the ones who do the beginner track for us. And Paulina, who saw Paulina 2 weeks ago? She is awesome. Yeah, she's really great. And Morantis is really great. And if you don't know Morantis, they are the pure OpenStack company. They do nothing but OpenStack. They're also the Russian mafia. I'm convinced of it. Yeah, anybody who knows them knows what I'm talking. They're all Russian, and that's totally not fair. They're not all Russian, but yeah, they're a good group of people. I really like them, and I like the Red Hat people. I like the Rackspace people. Oh, I'm sorry. Somebody asked about Ames. Oh, what? Then I said I was going to get around to that later. So after Al is done with us, I'll talk about the history of OpenStack.
No, you can't talk.
Yeah. So that's it. Let's move on to get to what I actually wanted to do. So chapter 3. Now, this book, as all the documentation in OpenStack Foundation, is written in DocBook. DocBook is an XML format that gives you all sorts of flexibility at the cost of usability. It's really hard to use, in my opinion. XML, I think we all, as professionals, get what XML does. And I think as professionals, once you start looking at other people's XML, you go, oh my God, what the heck's going on here? And that's what this is like. So it follows the same continuous integration system that the source code does. So if you want to change the documentation, you'll get your XML editor, you'll check out the project from Git, then check out the documentation project from Git. Navigate using, ideally you have a really good XML editor. You'll navigate down into the product and find that place where the period was missing, or where you didn't like, where it was passive, and you'll fix it. Then you save it and submit it to your Maven test unit, and it'll run through Maven, which sometimes can take quite a bit of time and put out error codes that make no sense whatsoever. You can kind of tell I have an opinion about this. Once you've got it passed through Maven, you can then check it in, do a git pull request, and the technical leads, Pranav, are you there? He's not on there right now. Pranav in particular was one of the technical leads. I'm not. I kind of stay out of this. They will look at what you've selected and then put it in branch, in a trunk, and then it becomes part of the documentation. It's organized in a way, there's this Start Here chapter and this preface and this introductory OpenStack training under construction, which is a long, drawn-out explanation of what I just said, basically. Building the training cluster is, how many have gone through that part? It started. I have not gotten it to work, but that's partially because my laptop has been sad. So that basically talks about how to install OpenStack on your machine, and also how to get it running. Then community support goes into what I just talked about, the contributions part. So this whole Start Here is really for writers. And only this part here is if you want to go through the training, you need to run the building thing so you have something to use. You could run this training on one of the public clouds. Question? Yeah.
Yes.
Yes and no.
You have to use 3 virtual, according to
this particular architecture. Yeah.
You have to use 3 virtual machines. They basically saying that the best is, or the documentation follows, and there is screenshot how can you configure your virtual machine in VirtualBox. You can use VMware Player as well. That's free, I guess, for training purposes. But the documentation is basically on VirtualBox. You have to use 3 virtual machines, and it's recommended at least 4 gig RAM. But I really recommend, in my experience, that you at least 8 gig RAM and a really fast SSD.
Yeah.
Because if you want to use a normal hard disk, you will sit there forever.
Right. Right. And this is part of why I want to turn maybe this session in January into an install fest. And maybe one of the things we do is we just go through. Who was asking about which commercial environment? Maybe we just split the room up into 4s, and we do DevStack in that corner, and we do Fuel in that corner, and we do HP Community Edition in this corner, which you really don't want to run on a laptop. Yeah.
And how much it can help us, small shops to do a lot
Yeah.
of things.
So as I promised, I'll talk to you about HP Community Edition after the meeting. Yeah. All right.
The reason I asked you about HP training and all that.
Right.
I kind of wanted to follow up with what kind of hardware they use. I mean, do they provide you with some connection to the data center with some machines? Or like
The moonshot. But moonshine would be cool too. Yeah. Yeah. That's not a. That's an expensive thing. Actually, it'd be an interesting idea.
Yeah,
More of a target machine.
During training, you do logging on AWS or HP public cloud to allow your students.
So again,
to do handout.
there are 5 departments that I know within HP that do training. I'm not sure all of them are commercial; they're public facing, but I know 5 divisions doing OpenStack training in HP, and I'm pretty sure each one of them does it differently. And that's just within HP. Can HP land? Wouldn't it be cool? Maybe someday we'll have. I mean, they're here. We could just have them roll in a moonshot on the floor here. Now that would actually, moonshot's not really a good tool for OpenStack demonstrations. It's good for a target machine for OpenStack. I mean, you could allocate some time on it. All right. Well, no, that's not a problem. I think that would be cool. I think that's a great idea. In fact, we probably would use the cafeteria then because we need more elbow room. And basically have a LAN party, but do it for Install Fest, right?
When I started using Linux in '94, very soon after that,
Yeah.
I was part of the Linux users group.
Right.
Doing Install Fest once a month. And
Yeah.
installed laptops or whatever for many engineers.
Right.
But I kind of fell behind, so I'm not.
Yeah.
Doing that on OpenStack.
You know, I'm probably going to make somebody mad, but maybe we could just invite Red Hat and Mirantis and all those, and we could just, like I said, each find a corner here in the same building, and then you come in and you decide which corner you want to go in, and we could run commercial Install Fest that way, and then we could like speed dating. You could like rotate. Okay, I'm just thinking out loud that wasn't a promise. That wasn't an official HP statement of any sort.
If you look at MySQL Community Edition works well.
Yeah.
Also, Red Hat Fedora also works well. If you don't want to pay Red Hat.
Yeah, no, exactly. It does. It's nice. And the Red Hat people are beautiful people too. So, okay, let's move on. So the book, again, it has that start here thing. And I just want you to be very clear that the start here thing is really preparation for the training and background for the training, and it's rather intensive. It's rather long chapters. So it can be a bit frustrating. There we go. So I'm going to close that. So I opened it. I want to start here. Then there's this getting started part, and this has the history. You're asking about Ames research was right there, and I keep pointing out the window, which is literally I'm pointing to Ames runway. And this has the history and the introductory text, and all the blah 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 about why you want to have a cloud. And, oh no, what happened? This is why I don't like this computer. So we'll wait. It came back, thank you.
This is for the Icehouse release?
They've updated it for Icehouse. I have not doubly checked that. I haven't gone through the whole thing since they've updated it. But I have noticed that every reference I've seen says Icehouse. But that said, I've also seen references to Quantum still in here, so let's not go there. So that's the getting started, and then there's a quiz, because this is training, and I think this quiz, is it populated? Come on. Yeah, this one actually has some questions here. But the one we really, this is my favorite chapter here, is the controller node.
Is MySQL necessary or
No.
any other database?
Help me out here. What else is Postgres supported?
SQLite?
Anything that supports SQL technically is.
Right.
But
It's only okay. Okay.
SQLite will work. Because that is very well.
No, that's what I thought. DevStack was based on SQLite.
It
Just-
should work because
Yeah.
SQLite can work without this.
Mm-hmm.
Using DevStack on a single computer, how do you interface with the Nova? You do that by a web server?
So there's actually this actually so there's the Horizon web server, and there's also the command line interface.
So you have to load several clients in order to do that.
OpenStack is a bundle of clients. Not clients. It's a one client. I'm sorry. Through Horizon, use your web server. Through the command line interface, use SSH. So you would.
Don't you have to have several clients?
No. Well, you could, but.
A list of different packages. Block storage, compute, data services, identity, image service, and so on.
DevStack doesn't install all of those.
Well, DevStack, okay, that's what I was
It
trying
all
to
runs
ask.
contained in one store.
Okay,
You edit your DevStack script.
so how do you call up the client?
Just whatever the IP address is. Like you point your DevStack's going to have your which interface you're using, and it's use the web client or SSH or you do an API call.
Okay, so that all comes with. DevStack.
Yeah, at the end of it, you just have it. I mean, they even tell you here's your IP address.
Oh, good.
Right. Another session I was thinking we could do is a DevStack install, but Sean really wants us to use the installer here because it's more real life. If you're going to be an administrator of OpenStack, this is the instructions here are what you want to follow. There's actually, I tell a lie. This is the associate guide. It's there's 4 books. Did I mention that? There's 4 books. This is the associate guide, which basically is about using OpenStack. The next one is the operator's guide, which goes deep into the installation. That's the first one that really covers installation. It actually redoes the installation in the getting started part. It goes very deep into that, and it goes into administrating OpenStack. And so theoretically, once you've passed the operators class, and if we ever get around to actually formalizing the certification, you'll get an operator certificate, and then you could go into any data center and work on OpenStack.
In terms of Horizon, is there other variants of the web interface other than Horizon?
No. Okay.
Horizon is
This is another good point. Part of the governance of OpenStack that lets us not need a benevolent dictator is we use lawyers. And there are lots and lots of rules about what you can do to claim to be OpenStack. One of those things is you must use the controllers, the Python code in the controllers from the main trunk. You cannot re-implement it in any other language and still call yourself OpenStack. As computer scientists, we all know we can take any API and implement it in anything we want. I can see a really cool project and re-implementing it in Go, for example. But that would not be OpenStack. And Horizon is the one. I'm sorry? To keep everybody on the same playing field. So if it's an technically you're correct, but from the foundation governance point of view, they don't want fragmentation, and if you start fragmenting it, then the name OpenStack becomes meaningless and the whole foundation falls apart. Well, VMware is proprietary, and again, they're kind of under a benevolent dictator model. They've got their management structure, and they do follow the same idea. But we have a model that's run by the foundation lawyers, and all the contributors, IBM and Rackspace and HP and Mirantis and all the way down the line, have not found that an onerous thing. And if we're going to create a standard, then we want to stay to that standard. We don't want to split the party up.
This is for each and every service in OpenStack?
Yes, every controller in OpenStack is written in Python. If you're going to use the OpenStack box, red box logo, you have to use code generated from trunk.
What about the plugins?
Plugins are a different story, right? And that's why there's so much competition at the network space, right? All the, Cisco and Juniper and Brocade and all those guys are fighting, and all the little players are all fighting tooth and nail because they've got, every one of them has the best SDN implementation of any of them.
As well as server side.
Right.
And I believe probably those certain founders of OpenStack, they are Python. And there are some Python fans. There are certain things Python cannot do or does not do well.
Right, but with the plugin model, it doesn't matter what it's implemented in, so you're okay there.
So talking about the code, they have to use the code. I'm talking about the interface horizon. So is that compulsory that to manage the resource, you must use horizon? You can't create your own variant.
You could, but you can't sell it and sell it as an OpenStack, and you can't sell it under the OpenStack trademark.
All these enterprise companies that have their own variants, are they all using Horizon, or have they gone off and created theirs and abandoned the path OpenStack?
That's a good question. So, for example, HP Cloud, which is the one I'm most familiar with, we basically run a version of Horizon that we've reskinned. I think the base code is the same. I think the Python code is the same, but the skin, we've changed the CSS so it looks different, and we rebranded it as Skyline, for crying out loud.
Horizon should not be required as a required component.
Python?
Horizon.
Oh, Horizon. So actually, what we're getting into now is what's known as core, OpenStack core. It's a very controversial endeavor within OpenStack. A guy by the name of, what's his name? Really a great guy, another great guy. I want to say Rubenstein, but I don't think that's his name. Anyway, he's running the core definition thing, and this has proved to be a lot harder than they anticipated. They have some rules, such as you have to use Python and you have to use the controllers from the core trunk. But what set of controllers do you need to implement to say that you're running OpenStack? And I alluded to this before. If you're just providing a storage system, if you basically want to make your business the same as Box.net or Dropbox, you could use Swift, and you really don't need any of the other controllers.
And Swift is object storage.
Swift is object storage, which I really object to the term object storage, but that's another issue because it's not state in behavior. It's database objects, which is it's objects from DBA land, and I don't talk DBA. Anyway, sorry. If you're DBA, I apologize, and I duly respect all your DBA point of views, but those are not objects. I'm a programmer, damn it. And I'll talk about that after Al gets done. I like picking on you. Where was I? Components. Oh yeah, the core components. So it turns out that defining what core is, if you're going to implement core and say you're going to implement a service and say that you're based on OpenStack, what set of components you need to do that legally is a very hard definition, and it's a debate that I've been watching for over a year now, And as far as I know, they've made no progress on it. They're still working on it. It's a very complex thing. And like I say, if you're one of the Swift engineers, you don't care about anything else because you can just do the whole thing in Swift. If you're a Nova engineer, well, with Nova now, canonical would be you have to have Nova and you have to have Cinder and you have to have Neutron. Then you would need Horizon and you need Keystone. I think, to me, that's pretty much core. But that leaves out Heat, for example. And again, if you don't know what these are, I will go over these code names later. It leaves out Trove. I mean, theoretically, you could just run Trove. I'm pretty sure standalone and deploy database engines all day long. Though actually, you need Trove and Nova because Nova would have to go through. Yeah.
Why OpenStack over time becomes more and more similar to AWS? Comparing to 40 years.
Well, that's not such a bad thing. First of all, AWS is a mighty fine service. Well, again, I won't go into that. So I'm going to drop that for now. And I'll talk about that later. But AWS is a mighty fine service, and early on in the OpenStack project, they thought they were going to basically implement AWS, but they decided long time ago that that wasn't necessary, and so they've moved away from AWS patterns. They implement different patterns than AWS. And again, I don't know that history really well, but it's well-known history that we do not implement AWS. Or OpenStack doesn't implement AWS. Yeah.
More or less the same things.
Again, same things, different patterns. That said, AWS has way more projects finished and running than OpenStack does. Like their database deployer, whatever it's called, I can't remember the name. Anyway, which one?
RDS. Services. RDS.
So they've had that running forever. We're just now, Trove is still almost, well, Trove is good now, but it's not been good for a whole long time. What are some of the others? I mean, AWS keeps coming out with all these marvelous services that we don't even have. Yeah, we don't even have projects, or OpenStack doesn't have projects on them yet. We probably will. And there's a few projects that are in OpenStack that AWS doesn't have yet either. And again, the projects work through an incubation period. So you start a project. If you get enough momentum behind it, you'll be recognized as an incubated project. You have to stay incubated for a couple of revisions, and then you become a full-fledged project. Okay. Returning back to our book, chapter 3. So Horizon, and this is my favorite chapter because it's really, if you have an OpenStack system in front of you, this is the chapter that talks about how you can use it. But again, it's more like a manual than it is a training guide. So it goes through and talks about the OpenStack dashboard, which is Horizon. Anybody, how many of you know what Django is? Okay. You know what WordPress is, right? Okay. So WordPress is a content management system. It comes under the category of content management systems. There's several content management systems. Drupal comes to mind, Joomla, and Django is another one. Django happens to be one written in Python. So of all the projects in OpenStack, this is really the only one that's based on an outside framework. And it basically is a bunch of web pages that come up in the right order. Let's see, I'm going to go down a little bit here, blah, blah, blah. They look sort of like that and that. Yeah, that's kind of a flavor of what Horizon looks like out of the box. Kind of plain. And basically what you do is you set up, in this case we're setting up security. Did I pass some good stuff? So, yeah, again, I kind of thought I was going to walk through this a little more formally, but we're running longer than I thought, so I'm going to go a little faster here. So you set up your security groups. To secure the access to I don't think they can see that. Again, if you're on the phone or on the Google Hangout, you might want to follow along at docs.openstack.org/training guides, training-guides. And then we set up our TCP rules. Who's the networking guy? Who wants to explain this part? I don't do networking really well. I just follow these instructions and they work, right? So we're
setting up the neutron part of it, or just the?
No, this is just giving. This is a project basis. So you're setting up a tenant, I think here.
I think you are setting up an internal network for your future VMs, how they can be based on one network inside OpenStack, the VMs,
right?
And they can communicate each other, or you can define different networks. So maybe you have a bunch of VMs in one network and a bunch of VMs in a totally different network, and they cannot communicate each other. But you also have to
isolate the VMs,
yeah.
Right?
Security group or access control.
Right. Yes, this is access control stuff. Yeah.
How can you SSH?
TCP and stuff, your VM does not allow such. Yeah, it only can't allow your SSH, assuming if you don't allow the SSH group. So such kind of.
Yeah. There's your key pairs there. So there's your SSH. Import your key pair, and now you can launch your instances.
So do they have a network diagram?
They don't. I really wish they did. You're right. So maybe that's something we need to add to this. Is if one of you want to contribute a network diagram, that would be really handy. Like I say, I mostly play in the OpenStack in the interface, and I just follow the rules, and it just works for me. Oh, there you go. Well, there's a good question too. How do you differentiate those, right? Right.
You've got the, I mean, if you're running neutron, you've got the, it has a cool diagram.
Yeah, that's actually a really nice feature too. That's my favorite feature. I don't. You can't see it. Again, if this was a live demo, I'd just click on it and I'd show it to you right now. Oh, that'd be cool.
So, I mean, that's going cloud, but it just shows your external network and then your private network, and then you get a virtual router. You see a host pop up.
This is the first networking diagram that or networking tool that I like.
Yeah.
That's also something I'd like to see more of a complex.
Which one to see? I mean, I'll sit here and hack away at one second. Just add a couple of tenant networks and a couple of routers, or what?
Yeah, like a router between say 4 or 5 subnets.
I think if you look at the architecture, network architecture for OpenStack, it does cover different use cases, like a flat network versus a router that is assigned to each project, and some private versus shared networks. If you look at those diagrams, I think we'll get a feel of what are the different ways of doing it.
You want the? Oh, there you go. Okay. Actually, if you guys can have a discussion, maybe go in the lounge.
Don't say anything.
Should I do the chalk talk now? Maybe I'll do the chalk talk now. Yeah. All right, that's what I'm gonna do. I can't do the chalk talk and wear the headset. I can at least get this in front of the camera.
I will be the laptop camera.
You're not gonna hold that, really? I'll just move this.
I didn't realize how can I do that. So
You can do multiple cameras, I think. Not sure.
sorry, everyone online. We will try to switch cameras here.
I like doing this because I've rehearsed this so many times I can do it in my sleep. But again, if you've seen it before, I apologize. So, oh, there you go. Oh, you got it working. Excellent. Okay. So the first thing I'm going to teach you, and this is worth price of admission. Don't care what you paid to sit here. This is worth it. I'm going to teach you how to draw a cloud. It's real easy. You just draw a bunch of semicircles. But for what you do is you draw the odd semicircles, and then draw even semicircles. Voila, you have a cloud. It's that easy, and it took me a year to figure that out. Just that easy. So, who uses a cloud? What is a cloud good for? I'm going to make the controversial statement that a cloud is good for only two things, and that is remote storage and remote computers. Everything else is infrastructure and is plumbing and is stuff you really don't care about as an end user from an infrastructure, if you're going to use an infrastructure. But not everybody uses an infrastructure. So let's actually talk about the user. Users want services. They want Flappy Birds or email or, spreadsheets. So this is where we define software as a service. Got a question for you. How many people know the car manufacturer that's spelled SAAB? It's a Swedish car manufacturer. How do you pronounce that name?
Saab.
How do you pronounce this?
SAS.
Why? Why is this not sauce? Anyway, sorry. All right, going back. So this is software as a service. This is the classic example. The poster child for this is Salesforce. All right? They provided all these great services in the cloud, and now we have, and you can say Google with Gmail and its search engine. Also, I want to point out, Google in general doesn't use virtual machines. They don't use a hypervisor, right? So you can't say that cloud is a virtualization technology.
You use a container?
They use containers, but they don't use hypervisors. So again, cloud is not a virtualization technology. Virtualization is a significant tactic in cloud, but it is not required. I just want to point that out. That's kind of the element of it. But these users want services. And the way I describe it is the cloud exists so you can use software without installing it. How many of you are old enough to remember going to Costco and had a table about this size and it was filled up to here with boxes of software? That's not cloud. Cloud is going to the App Store and pressing a button and the software just runs. That's what cloud is, right? Cloud is signing up for Gmail and being able to use your getting your email. Cloud is not having to run the installer. Cloud is well, it's also just software in the sky. Now, none of these services exist unless somebody builds them or programs them, and that's the developer. The developer looks at the cloud as a platform. An operating system is another platform. If you write to Windows, you expect a certain number of subroutines to exist, and you write your application to those subroutines. If you write to Macintosh, you have a whole completely different set of subroutines, right? In the same sense, a cloud developer is looking for a certain set of engines that they will program to. I think I forgot to mention this. Google and Microsoft are platform providers. They provide platform as a service, and you get something like a database engine, right? So I can ask Microsoft or Google or even Amazon, give me a SQL database engine, and I will upload my SQL code into your space, and I will run it on your engine. But I really don't think about the computers. I think about the services. I think about these platforms. Likewise, I might run a Java application. I would ask for a J2EE engine, a Java engine, or a PHP engine. Platforms. I would write my code to those platforms using those APIs. So to a developer, the cloud is a provider of APIs.
Is that the difference between the SaaS and the platform as a service is a bit vague, where you say.
These people don't write code.
Correct.
They use services. These guys write code that these guys use. And in fact, this whole thing does not exist without an end user. If the human beings go away, there's no need for any of this. This is not Skynet. You know, there's not compute. This does not exist for the purpose of the computers. This exists for the purpose of the end user. I am Tron. I fight for the user.
Like now, for example, you mentioned Gmail, right? It's like a software as a service.
Yeah.
But when you talk about platform as a service, you mentioned SQL.
An SQL engine. So, do you write SQL code? What kind of code do you write? Python. You have to have a Python interpreter. And so the Python interpreter would be your platform. Okay. If I don't install Python interpreter here, your code won't run. Right? So you want a computer, you need a computer, and then we're going to install the Python on top of the operating system and then load your code onto that computer and it'll run. And in fact, who manages the computers? The operators. My friends, bless their hearts, when they find, when I start talking about cloud, they all go, yeah, you need a computer. It doesn't run without hardware. And I'm like, yeah, so, but again, they're thinking in terms of computers. And operators deal with infrastructure, right? They're the providers of the infrastructure, which really is, well, it's CPUs and computers, it's storage devices, it's networking, a whole class of people here. How many of you are network geeks, or how many of you know network geeks, right? You guys fit under the operators. I mean, the operators, you're supplying the operators with stuff, right? I'm not a network geek. I'm a programmer. I fit over here more. Storage geeks. There's storage geeks. Gosh, bless them, but I can't stand them. They just go on and on about all this stuff that makes no sense to me. I totally appreciate it. Thank goodness they're there and they're optimizing the connections to the storage so it just runs really fast and it's always cached in the right place. And bless them, but I don't know how to do that. I know how to write code, and I expect that to just work. Without infrastructure is in all aspects of our lives. The lights, the classic example of utility computing, right? It goes down. We have utilities. There are people running generators all around the state. The local one that I know of will be in Moss Landing. I don't know how many people work in Moss Landing, but I'm sure it's just a few hundred. And they supply us with all this great power that we just expect. When infrastructure works, it's invisible. You do not appreciate it, and that's kind of the crime of infrastructure, right? When the water runs, we're having that problem here in California now. When the water runs, we don't really appreciate it, But infrastructure, when the roads do not have potholes, we don't really appreciate it. We complain when the road has potholes, but there's somebody goes out and takes the truck and puts the asphalt on and packs it down and makes the road smooth again. Infrastructure is everything. And without infrastructure, none of this exists. Without services, these guys don't care. And without these guys, there's no purpose for the whole thing.
You said platform as a service, Microsoft Azure is a
platform.
So
they mostly focus on. They will sell some infrastructure, but they're mostly focused on providing a platform.
They support both.
They do support both, but they're real. They're going to give you APIs. They really focus on their APIs. Google's the same way. Google has a very strong set of APIs, which is mostly geared around their apps, but they're very much API oriented. So they are considered to be platform as a service providers. as opposed to Amazon and OpenStack, which is more of an infrastructure as a service provider. Question?
No, no, just answer it. Amazon is more infrastructure.
Amazon's over here. All right. But and all of this is fuzzy. There's no hard boundaries between any of this. And you've raised your hand 3 or 4 times.
So can we say that cloud is basically a bunch of high-performing servers or database, basically computers, and where it's each set of machines are one set of machines having this operating system and one for the storage. Can you say that instead of having in your own building?
What you're talking about is private cloud versus public cloud. So when you lease your services or your infrastructure from another entity, like if you lease it from Amazon or you pay Google or Microsoft, that's public cloud. In fact, we have a data center in the next building over. There's most of the first floor is racks and racks of computers. That's our private cloud. And we run a lot of the same software there. And it's all our business applications over there. So, in fact, that's my business is actually, or our business here, is to supply all of this stuff. We provide infrastructure. Clearly, we make computers, for crying out loud. And we provide stuff to manage all this stuff. We're big in the management here. A lot of large companies use our software to manage their data centers. That's private cloud. There's some public clouds that actually use our software to run, but they also use IBM and Red Hat and all the others as well. Okay, so that said, that's just the marketplace. So you may have heard of DevOps. That's what this is talking about. The problem here is these guys write their code. It worked for me, worked on my laptop. They check it in and go on vacation, and these guys say, hey, it doesn't work. And in fact, to them, the application code is just another component in their infrastructure. And in fact, if your application doesn't work, they will find another application that's more or less the same thing, and they'll just use that instead. Just like they will go out and find another router. If the router that they're using isn't good enough, they'll go find another router and put that router in. Or if they find another server manufacturer, they go buy different servers. These guys are architects, and they just string together all these infrastructure pieces in these beautiful arrangements, these huge structures. So these guys don't respect these guys, and these guys don't respect these guys. Hey, it works on the platform. I wrote it to work on the platform, and you're supposed to make the platform work. Well, your code didn't broke on my platform, and yada yada yada. So DevOps was a guy who used to work in both of these camps. He was a contractor, and some days he'd be a coder, and some days he'd be an administrator. And he realized that this wall between the two is silly. So 5 years ago or so, he was in one of the European conferences, and he did a birds of a feather meeting at the very end of the conference and he couldn't think of a name, developer operators. He called it shortened to DevOps. And that was the beginning. You can find that article's online. There's articles online where this started. It's in Europe. And he actually got a good turnout for his thing, and the name stuck, and the movement has grown. And in fact, now there are people who consider DevOps to mean the breaking down of silos throughout the company. Finance to sales and everything in between, right? Just getting everybody to work together. So DevOps is really not, and I'm what's the word? I'm strict on this as well. Some of us are strict on this. It is not a position. It is not a job. DevOps is a philosophy of getting everybody to work together. There's another player in this setup that often is forgotten, and that's the businessman. And the businessman's job is he sees the cloud as contracts. And what he wants is money. And he's going to get the money from the end user. And that's not a bad thing. That's what business people do. Because the business person is going to want to please the end user, and to please the end user, he needs services. And so he's going to go to the developer, pay the developer to make the services. He's going to pay the operators to make sure that the whole thing is running. And they're all going to hold their nose as they talk to one another. So again, the part of the DevOps model is getting these guys to play well with everybody else. The thing is, they don't play well together, right? We have all these different people working together on the same cloud, and when they reach up and touch the cloud, they have a different idea of what they're grabbing. How many of you know the parable of the blind men and the elephant? Okay. So that's how cloud works. That's, and again, none of this exists without the end users. These guys make the services, the end users work. These guys make the platform that run the services, and these guys make the business work so it all hangs together and they coordinate the whole thing. So let's talk about OpenStack now. So in OpenStack, two entities started OpenStack. Rackspace in Texas wanted to compete with Amazon, AWS. They started off by making, I'm going to call it files. Actually, I'm going to different color. Well, no, files. Actually, I do want to change that. I'm going to change my color scheme now. They wanted to create files in the sky. Now, when you create files in the cloud, it's not the same as a disk server, or it's not the same as a file server. Basically, these files are accessible via a URL. They're not on your computer directly accessible from the operating system. You have to go through HTTP to get to them. The contract you make with the end users when they store a file up here is that you're going to get your file back. That's the contract. How do we guarantee that file does not get lost? Redundancy. So this system is designed to store every file that's uploaded into it, not once, not twice, but 3 times. And the system constantly monitors itself, and if one of those 3 copies goes away, is not accessible, it works like mad to get that 3rd copy running again.
And those 3 copies, they make sure they reside on different...
And they reside on different locations. And
that is very inefficient way of doing it.
It's not efficient, but it's reliable. And this is not about, but it is efficient because what we can do is by running them on little computers, a lot of little computers with relatively cheap disks, and by using redundancy to guarantee access, we can actually build a system that is massive, that stores a massive amount of data on relatively cheap hardware. This is the Google model.
So actually, I would argue that this is not an efficient way to do it, and I think that efficient systems use the RAID model, which means that they split file into number of chunks.
I understand what RAID is, but RAID has its...
With the same thing,
yeah.
But it's done on different servers, so you have the same effect, but you don't use that much space because you don't copy the file multiple times.
But again, with RAID, you need a certain class of storage devices, and with this system, you can use really cheap storage. And you can spread it out across cheap computers. It's just, this actually scales. There's lots of economic papers. This is for mass storage. This is cheaper.
I'm just saying that they don't make copies with efficient systems.
Yeah. It's not built for efficiency. It's built for reliability with a lot of cheap data. Again, this is the model that Google's based on. Well, one of the models Google's based on.
Each of the 3 copies could be in different.
They have to be in different locations. They have. That's one of the other rules. Okay. But the other nice thing about this model, it also scales really well, because if you start running out of storage, you just add another server with some more disks on it. And then you start running out of storage, you just add another storage. So as long as you have network bandwidth, it just keeps growing forever. Okay, so that's one school, and that was by our friends at Rackspace in Texas. Over here, they also wanted to provide virtual machines to their scientists at Ames. And what they wanted was computers, basically virtual machines. And they wanted to be able to deploy a bunch of computers to the scientists could use them, and then when they're done, throw them away and bring up some new ones, and virtual machines. This was the beginning of OpenStack, and there's a great paper in Wired magazine, I think it's called The Rainbow Mansion, if you want to look it up, and they talk about how OpenStack got started. They actually don't talk about the technology hardly at all, but they talk about the players and they talk about the unique environment that allowed Rackspace and Ames to get together and start OpenStack. And eventually other players, including HP, joined them, or soon after that HP joined them. You need a user interface and you need a directory server. And this is going to give you your users and groups. Now, in OpenStack terminology, groups is never called groups. They have two names that mean the same thing as what you and I understand as groups, and they're going to call them tenants or projects. So groups, tenants, and projects all mean the same thing. And I believe it's Swift uses projects, and Compute uses tenants, but I forget. It's one of those weird things that you just have to live with. Okay, so now we're getting pretty good along here. The computer part did a whole lot of work, and it started to get kind of unwieldy. So they started to break off parts. And one of the parts they broke off was disk. So the virtual machines come up. Now, how many of you use some hypervisor virtual machine? You know? And one of the things you specify is how much disk storage you want. But you all know when that virtual machine goes away, the disk goes with it. That disk that goes with it is called ephemeral storage. But what you want is disks that last. That's what this is. Now notice, disks are not files. This is a disk. And so that'd be like saying that the disk in here is a file. No, the disk contains files. These are files that you access via URLs. These are disks that you access via the operating system to go into the file system and find the files. Right? So there's disks. And these disks, you can save, you can create a disk, fill it up with an operating system and with a bunch of files with all your SQL data or whatever, and then store it. You can actually move it into this as an image. The other thing you want to store here is network information. So they pulled off network information as software-defined networks.
Could you repeat the last part? You mentioned disks moving into files?
You can. I'll get back to that.
Okay.
So, network. So the idea, this whole new branch of science came around, which is software-defined networks, where you basically define the configuration of your networks and let the software figure out how to actually physically hook it up. And it's software-defined networking. Like I said, that's where all the competition is now. And if you work for Cisco, you're trying to kill Juniper, which is trying to kill Brocade, which is trying to kill everything. And that's okay, you know. But they're all working together for the common good of humanity. Where were we? So blah, 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 blah. What am I missing? Oh, glance. Okay, so there's one last part, which is snapshots. You and I know these as snapshots. When you create a VM and you run with it for a while and you take a snapshot of it, which saves it off, which means you can go back and restore that snapshot anytime, then you run with it a little further and make another snapshot. For whatever reason, they do not call these snapshots in OpenStack land. They call these images. All right, so those are the. I'm going to call this core for now. There's a lot of other parts, but this is kind of the story gets too long if I go into the other parts. So now I'm going to reinterpret these. I'm going to give them the code names. So files is called Swift. And again, they don't call them files, they call them objects. And I hate that name. And this is a DBA term. That is a DBA object. That's a blob. Blob. I wouldn't have minded if they called these blobs, but they don't. They call them objects. These images, this, Nova. Nova is the big kahuna in OpenStack. That's the most complicated part. This guy basically is a web service that calls out to hypervisors, which we're going to call the compute nodes. And the compute node then creates all the virtual machines off over here. But Nova is the manager of that. Okay. This guy down here is called Horizon. And it's based on Django. This up here is called Keystone. And not only does it use user and groups, but all the keys so that all these things, all these components can talk to one another. is all comes out of Keystone. So you go to Keystone. The first thing you do when you go into here, well, you go into Horizon first, and then Horizon goes up to Keystone and says, are you who you say you are? It authenticates you, and it says yes, and it gives you a key for you. And then it says, okay, have Nova, talk to Nova, and it sends Nova a token, and Nova token, blah, blah, blah. All these things talk together with tokens. And the tokens come from Keystone. And there's, again, some splitting up in that node, in that area. Networking is called neutron. And you will see this sometimes called, in older documentation, call that quantum, but quantum had trademark issues, so they changed it to neutron a couple of issues ago. And disks are called cinder. Get it? Cinder blocks.
Right, so those are the block devices.
Those are block devices as opposed to files, a file storage system. And again, files at the end of URLs, accessible by URLs, blobs at the end of URLs. And then snapshots is called glance. That's pretty much all you really need to know to get started. And believe me, this part here in particular was real hard. The combination of files and disks and snapshots, they don't call them that, even though that's what I would have called them. And I think most people, that's how we mostly talk. But almost all the documents and all the books and everything talk about objects and images and block storage. But it's really files and snapshots and disks. Now, Glance doesn't really have any storage unto itself. It uses either files that are stored here, and then it will download them into the ephemeral storage here and run that, or it can call up one of the Cinder stored images, hook that up to the Nova unit, to the virtual machine, start it up from there. So it's a manager of images, but it is not the image storage. The storage is in one of these two places.
Mind if I just made a that?
You may.
That is a nice little concise.
Thank you. I agree with you. I've been telling this story for 2 years.
I hope Mirantis is going to release their the way the API and
yeah, Paulina's. I call that the Rube Goldberg story. Yeah, that's real interesting.
That's really a good way of.
Yeah. So if you come on next 2 weeks and go to the beginner pack, Paulina has a story about how all these things talk to one another. She basically goes, I call it the Rube Goldberg story, because the command comes in, it's kind of what I started to say, command comes into Horizon, the Horizon goes to Keystone, it returns the token, then the token goes to Nova, Nova gets the token, and then it generates the VM, and then it gets then connects the network, and she goes all through how all that stuff works. It's brilliant.
So what protocols are used? What protocols are used that communicate between all the different components?
TCP/IP. Thing.
Well,
I think it's a RESTful.
Oh yeah, it's RESTful. The RESTful interface is over TCP/IP. Yeah. Good point. It's all RESTful. So, does everybody know what a RESTful interface is? Okay. So RESTful interface is basically Tim Berners-Lee, hallowed be thy name, for he has fed my family for all these many years. He invented the World Wide Web. Literally, he came up with the World Wide Web. He based it on all sorts of existing protocols and whatnot, but without Tim Berners-Lee, he basically invented two things, HTML and HTTP. HTML to describe pages, and HTTP as a stateless protocol for communicating between pages. Statelessness is next to godliness, whatever. Anyway, statelessness is very important because it vastly simplifies the servers. Because all it is a get command, the server responds, and the server does not contain any information about the client. In fact, that is the key difference between HTTP and any of the other popular W3C? Whatever, any of the other internet protocols at the time, RFCs at the time. All the other protocols at the time, STP, UDP, not UDP, STP, SNMP, all the other ones, they all had some concept of FTP, concept of state, where the server had to keep track of the connection to the client. That's expensive. HTTP eliminated that and made the internet possible, because basically the Pareto rule of 80-20 says that 80% of the access is just reading. And there's no need to keep around state information for simple reads.
Is that true even for storage?
Not for storage, but I think it's still true. But I think connections became important. In fact, there's a whole industry. In fact, most of the industry now, you keep stateful information, but you keep it in a way that's not in the protocol. You keep it in other ways. A gentleman by the name, I think is Richard Fielding, he came up with his doctoral paper that he called Representational Entity State Transfer. I might have that completely wrong.
Like 12 years ago.
It's at least 12 years ago. I've read it. It's not an easy read. It's interesting. I thought it was real interesting. I highly recommend, if you're an academic type, it's a very academic paper, and basically it is Fielding, right? Is it Richard Fielding? The paper, it was his doctoral thesis. Yeah, UC Irvine. He was a UC Irvine student. But he had worked on HTTP, he was a significant contributor to early HTTP. And he came up with this notion that said the reason the internet works is because it's using a transfer, representational entity transfer, state transfer, which basically means that I'm reading data, and there's ways to make, and you can use caching to make that efficient, and we have timed caches involved, and all of this stuff works because it's 4 simple commands, maybe 5, which replicate the CRUD. How many of your database guys know what CRUD means? Yell it out. C, create, R, read, thank you. U, update, D, delete, right? HTTP does the same thing. Read would be get, update would be post, remove and remove, I think, are the same name. What am I missing?
Update is put.
Update is put.
Create is post.
Create is post. Create is post, update is push, and read, and delete. So because we have this very simple protocol that does not require a state to be maintained, it made the internet famous, and you can design a system that is quite robust using just those commands. If you need to maintain state, what you do is you transfer keys in the payloads and then maintain the states without having the connections necessary. Something like that. That's basically what REST means. So REST basically puts everything in the payload, not in the protocol.
By the way, dissertation was done by Roy Thomas Fielding, and it's titled Architectural Styles and Design of Network-Based Software Architectures.
Okay.
And in that he goes into the REST.
And REST stands for Representational Entity?
Let's talk about it.
Yeah, it's state transfer. I know it's state transfer, but I can never remember the first two. It's entity. I'm pretty sure E is entity.
It's just representation.
Yeah. I like to say basically it means data don't move, which means data doesn't like to move around. And if you can avoid having the data move, you basically, if you can read data, if you think of reading as like I'm reading that picture right now, I'm not moving the picture to me. I'm reading it over there. If I can read that data, it's much more efficient than bringing that picture over to me so I can incorporate it into me, right? It's a philosophical.
VMware likes to move data around.
VMware loves to move data around. Well, and actually, AWS makes most of its money on moving things between availability zones. That's where they get their big bucks, as any cloud service would. Availability zones are where you put the data center close to the user, or cache the data close to the user. And by moving that data, that's expensive, and so you're going to charge for that and make a lot of money. Yeah.
So, the explanation of the cloud. So the only difference between the private and the public cloud would be the infrastructure.
Who owns the infrastructure?
That's it.
Yeah, exactly. That's exactly what it is. And of course, there's all sorts of creative ways, So I could co-host something, which means I own the computer, but it's in DreamHost's area, right? All right, folks. We are running.
This mechanism of OpenStack is deployed The earlier ones like Cloud Stack and Euclid, how did they differ in the mechanism that OpenStack is?
I'm not real familiar with Amazon's patterns, but basically they took Amazon's APIs and took the API and used those to implement those patterns. And I believe Eucalyptus specifically is written in Java, if I'm not mistaken.
So the uniqueness is writing it in Python as compared to Euclid.
No. So these guys took the patterns, but not the APIs. So again, and you guys are going to have to help me out. This is S3 in Amazon space. If you know Dropbox is a very thin business layer on top of S3. It's a brilliant business model. I wish I had invented it. Very little software goes on top, and it basically means you put your file in here, then it uses S3 to store the file in the background, and then they use some sort of rsync mechanism to synchronize them. EC2, Elastic Compute Cloud, Elastic Compute something. I don't know the rest of them. Block is EPS.
Heat is
CloudFormer, yeah. So Heat I don't have on here, which is orchestration, which is basically running algorithms and all this stuff. And that's yeah. It's I want to say N3 just because it sounds right, but yeah, I don't know. I read a book on Amazon 2 years ago, and I really haven't used it since.
And regarding the original question about public versus private, say depends on who owns it.
Depends on who owns the infrastructure.
Who owns the infrastructure?
Who owns the data? Most precise, who owns your data center, right? Right. Who buys the racks and pays for the electricity, and who pays the people to put the computers in the racks? That sort of thing. That's infrastructure, and so, like I said, we have one here, Amazon next door to us. Which, by the way, these are the people who do the Fire phone and do their tablets. They do the software for the tablets next door. I'm sorry, yeah. 128, Lab 128. That's next door. But they're not the cloud people, as far as I know.
So where does Mesos and Docker, all these things today?
Okay, that's completely good. Docker and what?
Mesos?
Oh, I don't know anything about Mesos. It's another container. Oh, say containers. All right, you want my container speech? I haven't given this one in public yet, but it's really good. I've given it a lot to individuals. You've heard this one.
No, just yeah, this year.
No, you've heard this one. I gave you this one last 2 times ago.
Oh yeah, Dr. in the containers, yeah.
When I was a mere boy here in Silicon Valley, there was a company here called Timeshare. Anybody remember Timeshare? Timeshare had this really cool idea. They bought themselves IBM mainframes, and then they sold their customers time on those IBM mainframes. That was a brilliant business model. We now call that multitasking or multiprocessing. So let's go back. I don't really have pictures for this one. I need to come up with pictures for this one. You have a CPU, and the CPU has registers in it. And then over in memory, you have your memory space and you have your stack. That's pretty much how a program runs, right? I'm old enough to have actually printed out punch cards. I used an IBM punch card machine, very, very early machine when I was a teenager. And you take this stack of punch cards, you go up to a window, and you'd hand them to the guy behind the window. He would then take them over and put them in a hopper on top of all the other punch cards. And each stack of punch cards represented a program. And each program would run once, and then you'd get your output. And then the next one on the stack would run, and you get your output. And the next one, they only ran one program at a time. And this is machines as big as a washing machine, if not bigger. That's not multiprocessing. What Timeshare and IBM and others figured out back in the early 70s was that what you do is, now memory started getting cheaper, Moore's law, and they figured out that, well, I don't have to reuse this memory. What I can do, I now have more space over here, so I can give another program memory and its own stack. And what I can do is I can stop this one from running, copy all the register information off into a little bitty storage here, wipe this out, move the registry storage that I saved earlier here into this guy, point it to the stack, point it to the memory, and start running. That's what multiprocessing basically is. A very simple, overly simplified version of multiprocessing. And then as long as you have enough memory, you can run as many programs, different programs, and swap them in and out. Now, the program that swaps them in and out nowadays is called a kernel. That's basically what Linux is. Linux is a kernel written by a kid in Finland who then became very famous. But there's lots of other kernels around.
It's a scheduler, isn't it?
The kernel is a scheduler.
Oh, the kernel is a scheduler.
The kernel's main purpose is a scheduler. Okay. The kernel also provides the interface to the BIOS. The BIOS is a standard interface to other components, right? But the kernel is the scheduler. The main part of the kernel is the scheduler, and it's swapping in and out the process, and that's what we call multiprocessing. Move forward in time a bit, and somebody figured out that, well, an operating system and a whole computer really can be emulated as a program. And so they started emulated virtualization. And those are programs that pretty much run the chip and the operating system and the whole motherboard and everything in a program. It's not terribly efficient, but it worked. And then somebody, probably over at VMware, probably at IBM, because everything happened at IBM those days, or in a university somewhere, they said, well, the chip isn't changing. So let's not emulate the chip, let's just emulate the operating system and everything else, all the storage and everything else that goes with that. And that's kind of what we know as virtualization now. When you run Windows on your Macintosh, that's what it's doing. It's your Windows operating system and all the is running as a base process. And by the way, processes can have sub-processes and a whole tree of sub-processes, right? So we're going to run the operating system as the base process and anything else that goes with it, and we're going to swap the operating systems in and out. And then the people at VMware made a business out of rewriting the kernel, so pretty much all that's there from VM's point of view is just the kernel and the operating systems. There's every virtual machine is an operating system copy unto itself, and there's all sorts of optimizations where they use shared storage and whatnot. But my point is, you're swapping the operating systems in and out. The people who invented containers realized that, well, if I'm always running the same thing as chips, right? The chip is the same, right? So let's move that up a bit. If I'm running the same operating system, do I really need to swap the operating system in and out? Well, no. So let's leave the operating system there and just swap the applications in and out. And there's a couple more tricks we need to do. One thing we need to do to make these look like virtual machines from the application point of view, from the user point of view, we need to swap in and out the file system. Well, there's a notion of how many of you know what chroot is? Basically, you move where the root of the file system is all here, and I'm going to trick the application to thinking the root is up here. So we're just going to point the process is going to go in, and it thinks its file system root is here, so it's not actually being able to read any of the other file systems. I'm going to swap that in as a process, and then swap the other one in a process. And now what you actually have is the operating system is doing what the operating system does well. The kernel is very efficient. And what you end up with, by not moving the operating systems in and out, you actually have a huge speed change. So my favorite demonstration from the Docker guys, and I've seen this 2 or 3 times, he'll bring up a Redis database image. Then he will suspend it. He'll deploy, within 10 seconds, he will deploy 10 copies of that Redis database all running at the same time. Within 10 seconds, 10 copies. It's almost instantaneous. So now what it does is it's basically you're just running what looks like a virtual machine from the top down. You're not changing the operating system, but you're just changing the the application tree, and it looks like a virtual machine for all intents and purposes. The problem is, since the operating system isn't changing out, a lot of people don't think of it as a virtualization scheme, which I think is really silly, because in my mind, only pure emulation of the entire thing is virtualization of the machine.
Well, I'm not sure about that. Because if you run different operating systems, then you have real virtualization. When you're running, let's say, Linux containers or Docker, then you're not swapping in and out technical anything. You're just sharing a bunch of libraries because they're the same for every.
But from the user point of view, I don't care what operating systems are boring, to quote Steve Jobs. I don't care what the operating system is. I really only care about the services. And from that point of view, it's every bit as a virtual machine. But I will go back and I will still maintain that unless you're emulating the chip, you don't have a virtual machine.
No, you're not emulating chips.
Yeah.
Because VMware achieved something that nobody
But it's not a machine. At that point, it's not a machine. It's virtual operating systems, but it's not virtual machines.
VMware achieved something
I'm being
that
pedantic.
nobody else did. They talked to Intel and say, look, instead of having us emulate something, change some register or add them or whatever to the CPU that will allow us to do virtualization on the fly rather than emulate certain parts.
Sure.
And that really made big change.
Well, yeah, but also when Intel invented stack storage, going back even further, the idea that they started recognizing the stack as an entity within the firmware, to me that was a major change as well. Actually, not in the firmware, in the microcode. When stacks were recognized in the microcode, that was a huge change as well. So it's an evolutionary change.
Do the applications have to be written any differently?
Nope. Any application that runs on Linux right now, I can run on a Linux container.
That's for Linux. What about
And
the Windows world?
well, Microsoft ain't stupid, and it's my understanding. Well, for example, Azure will let you run a Linux box, and Azure absolutely supports Docker. Now, that said, it seems really silly to me. Thank you. It seems really silly to me that Microsoft isn't reading this, and to me, Docker is more important than OpenStack, in my opinion, because well, among other things, it disintermediates the hypervisor. You don't need a hypervisor with Docker, because what you may need a hypervisor if you're going to run several for maintaining the Linux base machines. But theoretically, you can run them on straight hardware too.
So we need virtual networks with Docker.
You still need the virtual networks. We're not doing away with that at all. So yeah, so Juniper and Brocade and those guys, they still love this stuff. Yeah.
So the follow-up question on that is like, so you're just swapping the application and then pointing the roots to Spotify.
Pretty much. And that actually was Linux containers, and which goes back to actually jails on BSD. So it's a long history. What Docker did was they made this whole thing easy to use. They basically applied what Git does to a Git-style interface to containers, and it makes it a whole lot easier. And their configuration files are teeny tiny. They're beautiful things.
So the application has to be configured.
Nope. The application just runs. What you have to do is you have to configure the container and tell it. Basically, the way it works is you bring up a Linux machine, and you very much use Git. It's very much like Git. You basically say Docker init or something like Docker new. I forget the exact commands, and that creates a container. Then you say run my application, load my application, and run my application. Then you say either suspend or stop or whatever, and you take a snapshot of it. And then you say, and then you store it. And again, just like Git, like a Git version, you can now say run it. The other really cool thing is you can take one of these images and you can like put your security software and add on all your security software, freeze that, save that image, bring it back. Now add your database on top of that, freeze that, and you actually have them separate. Right? So the database is actually an image that depends on the security image, which depends on the operating system. So you can you now have all these literally stacks of components, dependencies of components of containers. This is a whole new world. It's a beautiful thing.
In container
containers, how does networking work?
Again, from one of the things that you do, well, part of the state of the container includes all your IP tables and everything you need to know about your networking. So you can set it, as I'm running this container, I will set my networking addresses and whatnot, my state, and then I'll bring up another container and set up a separate set, and then it goes to a NAT system, basically, in the computer. The other interesting thing is they can route, as they route from one container to the other container on the same box, they'll use inter-process communication. So you get wickedly fast communications. You don't have to actually go through the network stack.
No, but does it use it automatically, or does it, you have to do something? Like, you have to do some sort of port forwarding? Or
yeah, you do, and that's all in this little tiny configuration file. And you have to. I don't know enough about this yet, but I highly recommend. There's a book by one of the Docker guys, and I can't remember the name of the book, but it's a guy who works at Docker. There's lots of books on Docker now. There's a lot of Docker meetups. They're very good. The Docker company's in San Francisco, and they'll gladly come out to your organization and give you a demonstration. I've yet to see. No one's ever explained it like this before. I personally think this is it's a background that makes the rest of it make sense. But usually, what these guys will do is they'll bring up their terminals and they'll start typing things, and you have to keep track of what they're typing, and you have to remember that 5 steps ago he set that variable, and I don't do that well.
There are a lot of like I said, there are a lot of YouTube videos and nobody explained.
Right.
So,
hi guys, this is Rick. I can use Docker. Look at this. That's my imitation of a YouTube video.
So it just sort of scares me, you're saying that OpenStack is sort of like a dead technology.
No, I did not say that.
I said it's so much better.
I said Docker is more important than OpenStack. I think in the long run, understanding Docker is more important. Understanding containers is more important than understanding OpenStack. The same way, I'm going to say something else. I think Linus Torvalds' greatest invention was Git. And he wrote it in 2 weeks. I think Linux is his second greatest invention. But Git has really changed the way we think. If you use Git, you think, right? You think completely differently once you learn once you grok Git. Everything else changes. And you start seeing everything as just large keys, large UUIDs. So,
one of the reasons was that Google last night. So it's on the month. Yeah.
I was there.
And they had very good presentations. So it's
I thought they were actually pretty poor presentations. It was very hard to follow.
Last night it was very simple to follow. The guy was very fast.
He was fast.
There was one of the companies that is kind of doing commercial thing around.
I thought that was a better presentation. That was called
from Oregon.
Speedify or something, or Shippable. What?
Shippable.
Shippable. I thought that was a very good presentation. I didn't much care for the first guy's I was following him basically. The only reason I followed him is because I've seen 5 or 6 Docker presentations before. I was really hoping for something better. That's my opinion. I mean, you liked it, so that's good. Yeah. And then I know a lot of other people have liked his presentation, and he did bring up some good points. But I was sitting in the back, and I could hardly read his screen too. He didn't know about Command Plus. All you had to do was hit Command Plus to make the font bigger, and I could have at least read it. Sorry, I'm opinionated. I apologize. Anyway, it's time to go. I have to kick you out now. I'll grab some pizza if there's any left, please.
Nice job, Rick. Thank you.
Thank you very much.
Thank you. What replaces
Bye, everyone.
Chef,
Docker usually does.
puppets, and so on?
What replaces it? I'm not certain anything does yet.